just on unit 5 and 5.1. So the first one we're kind of focusing on here is triangles, specifically right angle triangles, right? At this point, if we've all taken workplace 20, we should recognize the Pythagoras theorem here. That is that a squared plus b squared is equal to c squared. And again, quick reminder here, what is c? C is always going to be your hypotenuse. So c is always the hypotenuse. And how do you know what the hypotenuse is? It is going to be opposite of the right angle. So again, if I'm looking at this triangle here, I see this little square here, right? That's my right angle, which means that if I look at the opposite side of that, that would be my hypotenuse here. And it doesn't matter what I put for A or B with that, right? As long as I know what my hypotenuse is, I've labeled my triangle, I don't really care about the other two sides when I'm dealing with Pythagoras. So this is our, this is your formula for it. You will need to have that memorized if I recall. I am pretty positive. Let me. Yes, you do. Okay. If you haven't memorized that before, you definitely need it now. So this is something that will not be on your final exam. You will be expected to know this. It is expected that you will have this memorized. So, and remember, a big part of this is not just knowing that, oh, Pythagoras, that's this, and this is how I solve it. A lot of it is recognizing, as you guys kind of realize, is you do a lot of things with triangles. Which way am I going to use? Do I use trigonometry? Do I use like sine? Do I use Pythagoras? It's about being able to identify what am I actually trying to find. So when do we use Pythagoras? We use Pythagoras under two circumstances. One, with right triangles. So when to use? One is always with a right angled triangle. It will not work for non-right angle triangles. So if I give you a triangle that's like this, that does not have a right angle in it, right? It's not going to work. Now, I could turn this into one if I were to like split it up and stuff. That's when it would work specifically on like this part and this part. But it has to have a right angle. If it doesn't have a right angle, this is not a tool that's going to work for you. And the second part is we only use it. We use it when you have two sides and you're trying to find a third. Usually what I find is the issue is that most people actually know how to solve Pythagoras. They just don't know which of the many triangle theorems you're supposed to use at a complex question. That tends to be the issue from what I've seen. So again, you need to have this formula memorized. You have to know that C, your hypotenuse, is always opposite of your right angle. And you have to know that I use this when I'm dealing with a right angle triangle and when I'm trying to find a third side. Those are the two big ones. And again, the other like triangle theorems that we've talked about here is, well, this is Pythagoras. The other one is trigonometry. The other one is, we call it trigonometric ratio, but basically you have sine, you have cosine, you have tangent. Those are all on your calculator, but these are all those three different formulas. And just like before, you will need those memorized. And again, how do most people memorize this? They use SOHCAHTOA, right? That's how most people have this memorized. Like if you go and ask any random person on the street, hey, what's SOHCAHTOA? They will probably know. It's just one of those things that's glued in your head from a high school math class. So what does this mean again? As a quick reminder, SOHCAHTOA, the SOH, it's saying that, hey, the sine is equal to the opposite over the hypotenuse, right? SOH. CAH means, well, it's cosine adjacent and hypotenuse, right? TOA, TOA, it's tangent is equal to opposite over adjacent. It's looking at those first letters of all of them, right? Okay, so when do we use trigonometric ratios? We use this again. Ooh. So when to use?
We have one side or two. Yeah, when you have one side.
Well, the second you have any angles, the second you are using angles, whether it's two angles, whether it's one angle, doesn't matter. You're using this. Now you can use it to find a side. Like if you have one side and one angle, you can use that to figure out the rest of the triangle. You're right. But basically, if the second you have angles involved, you're either trying to find an angle or you need to use angles to find sides. You need to use this. And just like before, it's for right triangles only. That second point seems kind of redundant, but at some point we are going to work with non-right triangles. And there will be some very similar like theories in there. So a big part of these triangle theories and shape theory is knowing what to use and when. It's not just being about able to solve it in the topic here. It's when it's like, okay, I have 5 different tools. Which one is the right one for the job? So we are going to do a really brief review of these two things. So for example, if I'm looking at this question here, it wants us to calculate the length of the missing side. Well, what do I have here? I have 2 sides, and I'm trying to find a third side. Which tool am I going to use then? Pythagoras, right? I have 2 sides trying to find a third. I immediately know I need to use the Pythagoras theorem. Ew, Pythagoras. So just like before, I know it's been a while, but most of this class is really going to be solved with these steps, right? Which is identify the formula. Like, hey, what do I need to do here? We've identified that I need to use Pythagoras. That's step 1 is always what formula? Step 2 is always going to be substituted in. 3 is going to be solve and simplify, right? Most of the course can kind of be summarized as that, but I want it to be more than just, what formula do I use? It's important to recognize when we use these different theories and why we use them. So let's go through this. We've already identified that we need to use Pythagoras. So I'm going to do step 1, which is identifying my formula. Well, that is, oops. I'll make this bigger for you guys. It's a squared plus b squared is equal to c squared. Now, this triangle is actually built in as a trick question. Can anyone recognize the trick I've done here?
So it's got 2 A's, 2 B's, 2 C's.
Oh, so you're kind of recognizing, oh, you have an A here and A here. So we'll talk about that. But basically, big A means on the corner. And then this means like the little A is like the side.
Yeah.
That shows that's opposite to it. That's close to what I'm thinking of. What side am I trying to find in this triangle?
Well, C.
I'm trying to find the hypotenuse, right? Which we always identify as C. We know that C has to be the hypotenuse. But in here, what have I done? I've said it's A. So even though it says A here, this is still the hypotenuse. That is still the hypotenuse. So my trick there was I put an A there, even though technically this is saying that, hey, this is hypotenuse, which we represent as C. So I'm going to go into my next step here, which is substitute. Well, I already know that C, which my hypotenuse, is up here. I could put A here if I want. That's going to seem confusion. I'm going to leave it as C. But now I just have two sides remaining. It does not matter whether I do 7.5 centimeters squared plus, was that 9.4 plus 9.4, or whether I go 9.4 plus 7.5. It is the same thing. But the key thing here is I need to square these. So now I've substituted. My final step now is really just, let's simplify and solve, right? And again, your calculator can do the heavy work for you here, but I will say, here is a common mistake people make. So a common mistake people will make is they'll go, oh, 7.5 plus 9.4 is 16.9, and then they'll square that. We don't do that. Instead, this is saying that, hey, this is 7.5 squared, which is, I don't even know what that is, like this is 7.5 squared, which is 56.25 plus 9.4 squared. So actually, this is, again, most people don't write this step. It's an example. I'm going to do it. So what's actually happening here is they're saying, hey, it's 56.25. Oh, 7.6. Thank you. Okay. Thank you. Again, that's everyone makes those little mistakes, right? 7.6 squared, not 7.5, is 57.76. Plus whatever 9.4 squared is, which is 88.36. Sorry, this is equal to C squared. Now, most people skip this step, right? Most people skip this step, which is totally fine. If you just want to literally put in your calculator, 7.6 squared, oops, 7.6 squared plus 9.4 squared. If you just want to do this, write it exactly as I see it, that's fine by me, right? 146.12, that works. So 146.12 is equal to C squared, right? Now, we're not done though, because if I'm saying, hey, what's squared? Like something squared is an area, right? I don't want to know the area of the hypotenuse. I want to know the length of the hypotenuse. I want to know what C is, not what C squared is. So I need to do the opposite thing, which is square root it. If I square root C squared, I'm going to get C, which means I got to do it to both sides. Oh. So if I square root both sides, I will end up with C on the one side, which is what I want. That tells me the answer. Now, you don't want to write in 146.12. Your square root symbol is this little thing here, right? You don't want to write it in like this, on most calculators anyways, because it's just going to give you a big error. Your number has to go under that little line at the top. So you use the square root symbol and then you put your number in. So the square root of 146.12 is equal to 12.09. Centimeters. Now you could also say like 12.1. That would be fine in this case because the numbers you're given go up to one decimal place. It's usually going to specify. On like an actual test question, it'll specify. But as long as you're like, if you got any like semblance of it, you'll be okay. So again, just kind of a refresher there of Pythagoras.
So if they ask that, would you on like, for example, the test, like, would you actually have to put 12.09 equal A?
So what's gonna happen? What's gonna happen for your test is they're gonna give you this question, and they're gonna give you like an A, B. They're gonna give you a multiple choice. So like maybe they'll give you like it'll be like I don't know, 12.9, and then 16.9, like whatever that is, 16.9 squared, or like so. Yeah, so they'll you won't have to actually round it yourself. At least you shouldn't have to. There are a couple of ones that aren't multiple choice, but I don't see the rounding being an issue there. Yeah, they will probably give you like simpler numbers for that one. Okay, so I'm going to give you a little bit of time here to try out these three questions here. Like I said, this is just kind of like a review of some stuff. We need these as baseline skills. So I'm going to give you guys like 5 minutes here. Try out question A, B, and C here. Now you're probably looking at C and you're like, huh, there's a trick there. You're absolutely correct. So about 5 minutes, try that out. Again, if you're not sure, ask for help. It's important. We need these skills down, and we need them down today. Okay, so that's some Pythagoras stuff. Like I said, so that just kind of like was meant to serve as a bit of a review here. Again, if you have questions of that, please ask. Now we're also going to be looking at the trigonometry stuff as well. So we're going to do a really, really quick review of that one as well. So with trig, whenever I say the word, I use trig. That actually means trigonometry. Trigonometry. That's all code words for you're using right angles. Sorry, you have angles and right angled triangles. You don't need to write this down, by the way, but just so you know, whenever I say trig, this is what I'm referring to. It is saying that, hey, you have a right angle triangle and you're using angles in some way, shape, or form. The second there's an angle involved, it's trig. So again, and whenever we use trig, we are looking at these things. SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So you can use this in two ways. You can use it to find sides, or you can use it to find angles. So again, I'm just going to put this here just so we have it. So I'm just going to kind of also put the steps here. Let me make this smaller. So whenever we're using trig, again, just as a quick review, and this is on page 177, we always want to label the triangle first. So if I'm looking at this one here, I want to find the length of side W. What do I have to find it? I have an angle and I have a side. Oh, I'm using an angle somewhere. I know I need to use trig. So I'm always going to label it. Specifically now, I'm going to label all three sides. My hypotenuse is always opposite of my right angle. This is my hypotenuse. Now, you can see here, I'm given an angle here, right? I have this 41 degrees. The opposite side is always going to be opposite of that angle you're using. And whatever I have left is going to be adjacent. So you always find hypotenuse, then opposite, then adjacent. Adjacent is always whatever you got left over. So you have to label all three sides of the triangle now. The next thing we need to do is just like up above is we need to identify the formula. How do I solve this? What do I use? If I'm looking at this, I know I need to use trig, so I need to use SOHCAHTOA, one of those. Now, what am I trying to find? I'm trying to find the W, which is my hypotenuse. what do I have to find it? I have an angle and I have an adjacent side. So this opposite side, it doesn't matter. It's useless to me, right? But what I have is I have A and H. Which of these use A and H? Cosine. So I can see I have adjacent, I have hypotenuse. Those have values tied to them. Even though this is a big W here, that has a value tied to it. So I have A and I have H. Cosine uses A and H. So that's my formula. So how we say it is we say it's the cosine of, we say theta. That's the, I'll draw that symbol in a second. Oops, is equal to A over H, equal to adjacent over hypotenuse. So let me fill that in here. So cosine of the angle. So I have this just like before. Hey, I found my formula. The next thing is, well, I need to substitute and solve, right? So it's still the same steps as a lot of other things. So I've labeled it. I've done my formula. Now I need to substitute. So I have the cos of the angle here is 41 degrees. It tells me what the angle is. 41 degrees is equal to adjacent. It tells me that that is 4.2 meters divided by my hypotenuse, which I don't know what it is. It's just said that it's W. So what am I actually trying to find here? I'm trying to find this W. At the very end, I want it to go like this. I want it to be, hey, W, your missing side is equal to the answer. That's what I want. So this is actually an algebra question here. Because right now, what do I have? I have W down here. I need to get it away from this fraction. I need to get it by itself. So how am I going to do that? I'm going to do the opposite. I need to get it away from the bottom of a fraction. So I need to multiply both sides by W, which is going to cancel that out on the right side. But on the left side, I'm now going to have cosine of 41, times W is equal to 4.2 meters. Now, you guys are going to notice here, I'm putting a dot. Why am I putting a dot here? This is another way of showing times. Because wouldn't this be confusing if I did 41 times W? Right? Second year with algebra, like a lot of people like using these dots to represent multiplication because we use X a lot. And the symbol for multiplying is also an X. So it's really weird if you have X times X. So cool, I need to do that. But now also, I still don't have W by itself. I want it to be by itself. It needs to be isolated. So I now need to get rid of this cosine of 41. So right now, cosine is being times into W, right? So I need to do the opposite of dividing by it. So that gets canceled out. And I'm going to be left with W is equal to 4.2 times, or sorry, 4.2 divided by cosine of 41. So this is about like as hard as we got last class, right? It's a two-step trigonometry equation. That's about as hard as it can kind of get. But so now, remember, this cosine of 41, that has a value. That represents a number. It's not a very big number, but it represents something. It's equal to something. You know, sine of 45 is equal to something. Sine of 90, was that 0? Is equal to 1. It represents an actual number. So I can actually take this 4.2 and I can divide that by cosine of 41. I'm dividing it by a really small number right now, but it's gonna work. So it's going to be equal to 5.56, this thing, let's say 5.6. So it's equal to 5.6 meters. That's as hard as like the trigonometry we've done before it gets. Like I said, we're kind of in a little bit of a speed course here. So that was question A up here. Question B will be a little bit simpler. So question B asks us, I'm just going to scroll up for a second, is we want to calculate the measure of angle E. That's what this thing means here, is angle E. It wants us to find this. And I'm going to represent that with that little theta symbol here. That means angle, right? You could put X if you wanted to. That works. But it wants us to find angle E, this thing right here. So I solve it the exact same way. I'm going to label it. 3.9 is the hypotenuse because it's opposite of my right angle. 2.8 is the opposite side because it's opposite of my angle that I'm trying to find, which means this is my adjacent side here. So that's the first step, which is I've labeled my triangle. The second step now is asking me what formula. How do I know what formula to use here?
You just look at numbers and then so the O and H.
Yeah. Yeah, so you know I need to use O and H here because those are the two sides that have a value associated with it. Which means, so O and H, which ones uses O and H? You're right, sine uses O and H. So sine is equal to O divided by H, opposite divided by hypotenuse. So I'm going to put that in here. So sine of the angle, which I'm trying to find, is equal to opposite divided by hypotenuse. And again, you can put X for that if you wanted, or like anything. So now I've figured out my formula, just like before. I now need to substitute and solve. I know what my O and H are. I don't know what my angle is, so I'm going to leave that how it is. My opposite side is 2.8. And my hypotenuse side is 3.9. And so remember, just like before, what's my end goal? What do I want? I want it to tell me what the angle is. Hey, the angle, the theta, is equal to something. Here's your answer. So what do I need to get rid of to do that? I need to get rid of this sine, right? This is sine times the angle. So I need to divide by sine. Now, those of you who took this with me, you know exactly what's coming. So, okay, I need to divide both sides by sine, right? So what's going to happen here is I'm going to take, 2.8 divided by 3.9, divide the whole thing by sine. It's going to break your calculator. It's not going to work. You can't actually divide by sine, cosine, and tangent. It doesn't work. So again, you cannot divide by sine, cosine, and tangent. It doesn't work. Now you might be wondering, but what about right here? You literally just divided by cosine. I did not. I divided by cosine of 41, which we proved, has a value. that means something. But cosine, if I take 5, I divide it by cosine, it doesn't have a value. So if you have an angle in there, you can do that. Down here, I cannot just divide this by sine. It needs to have that number associated. So you trick your calculator. So what do you need to use? You need to use the second function. I'm actually going to write that down here. So theta is going to be equal to, it's called the second function of, it's going to be 2.8 divided by 3.9, just for space, and put in that slash there. Sorry, of sine. Or another way of thinking about it is sine to the power of -1 times 2.8 divided by 3.9. I'll show this in a second, but I just want to give you time to write that down. I'm going to assume you got that down for now. So again, how you trick your calculator is you use second function. So sine to the power of, there's this little -1 here. This actually means divide. So this actually means you're dividing something. So just give you an idea, if I say, hey, 5, which is technically 5/1 to the power of -1, is the exact same thing as 1/5. It's flipping it, is really what's happening. So I take sine over 1 of the fraction, 2.8 over 3.9. And it's going to give me a value now. So I've tricked my calculator into dividing by sine. That's really what's happened here. So 45.9. Actually, we'll just go straight. It's an angle, so we'll just say it's 46 degrees. 46 degrees. So the angle is 46 degrees. Now, these two questions were like some of the hardest types of ones we could get. We spent a week building to this. With the Pythagoras, I kind of need you guys to kind of be there with this. If you're still a little bit confused, that's okay. We will get a couple more chances to revisit this, especially because we went straight into the deep end here. But so what's going to happen here is, where did I put it? So just like before, we're not going to have a lot of time. I'm going to give you guys about 30 minutes here to work on a trig sheet. And again, please ask questions if you need it. So on the LMS, I'll load it up here for you just a second. You will find a trig ratios document. If you click that, you open it up. Just like before, you guys can work on whatever it is that you need to work on here. I recommend go hard. I would recommend not doing the first 6 questions. That's just put it in your calculator. Go to about as difficult as you need to. Ask for help if you need it. Some of these are really tricky questions. The goal here is to, again, test ourselves, see what area do I need to fix now, because we won't have a lot of time for it. We are on a schedule with this course, whereas with the last one, there was not a big departmental at the end of it. So what's happening there for the end of today? You can finish the trig worksheet. Go to the quote unquote hard questions for you, and everyone's going to be at a different place there, and that's fine. And ask questions if you need it. We're going to dive into the new stuff on this tomorrow.